I want you to do right now is I want you to pull out your purple Waves on a String lab. Some of you did not finish. This is your lab conclusion. So you want to add some notes to your graph. This might answer some of the questions on that lab worksheet, but I want to make sure to emphasize all the important concepts we got. Don't look at my notes. All the important concepts we got out of this lab. So let me dim the lights a little bit. Waves on a string. I want you to look at your waves on a string graphs, and I want you to compare it to what I show you up here. Obviously, there's some room for error. If you moved your device a little bit, or if your mouse was too strong, some students didn't get any change in data, you're estimating the length of your wave, so that could affect your data as well. But how many of you got two positively sloped lines showing that the wavelength and the period are directly proportional? You should have two positively sloped lines. Okay, good. That's good. Now, let's look at the equations that you came up with, your mathematical model. First of all, there are certain things you need in a mathematical model, and students always forget to put this. I don't want to see any y's or x's in your mathematical model. I want you to take your y-axis and your x-axis and plug them in for x and y. Then you're going to take the slope from your equation, but you still have to plug in the units. So my units are rise over run, which is meters over seconds, and I got 25.7. You're going to get something slightly different. And then your y-intercept needs to have a unit as well. All number values in a mathematical model need the units included. Do you have to include units for the variables? No. Some students want to include them. I never dock you for including them. What I do want to find, though, is you must have the units for your slope and your y-intercept. Now, I use my abbreviations here. Lambda, make sure you memorize, lambda represents wavelength, capital T represents time, and then this is the equation I got for my smaller wave, meaning less tension. So I've got more tension, less tension. So first thing I want to do is analyze this slope here. What do you think the slope of this graph means? I dropped my y-intercept. Some of you may have kept it, but in my case, I had a really small y-intercept that didn't fall above the 5%, so I dropped it. But if we look at our data, what does that slope represent? Any thoughts? Hopefully you got the same variables in your slope, but that's your clue. Anytime you're trying to interpret a slope, interpret its variables. What does that variable mean to us? I really hope it's something that you guys recognize. Adele. So this is the wavelength, this is the period, and then we've got this number here. It's 25.7 meters per second, or in this case, 18.9 meters per second. The meters per second, you've seen that before. What is it, Zen? It's the velocity, it's the speed. So now, we've got wavelength equals speed times period. That's your general equation. You always want to figure out, what does the slope mean? We also sometimes have a meaning for the area under the curve, but we're not going to talk about that for this type of graph. Now I want you to think about, your graphs might be different, but I want you to think about the tension. I have a high tension and I have a low tension. It's based on how heavy my mass was. So I have 150 grams for blue. I had 250 grams for red. Hopefully you have that labeled in your graph. But I want you to look at how that tension value affected the speed. So turn toward your group members. I want you to compare it with what data you got and tell me, after analyzing, how does the tension affect the wave speed? Turn to your group members, discuss it. I'll give you 1 minute and then we'll talk about it. Does your graph match what my graph has? It's okay if it doesn't. It's great if it does. Yeah, it's more tension.
Do you move it? Just feel like meters.
Yeah.
So you want to convert meters? Because we weren't supposed to. Oh wait. Centimeters? Okay, so it gets converted, right?
Yeah, so it should be 30
Okay, and what about the lightest?
If that's also
That's obviously drops, right?
yes. Yeah, it's hot, right? Okay. What did you come up with? Who can tell me what's the relationship between tension and wave speed? What do you think, Mason? High tension equals high speed. Look at our warm-up. That's exactly what we concluded. That's exactly what we concluded from the Slinky lab, that high tension equals high speed. So this is reinforcing that concept. Okay, moving on. Oh, I wanted to ask, how many groups got high tension means high speed? I just wanted to see how accurate you guys got. Good, awesome, perfect. Okay, let's go on to, we already know, so high tension, high speed, these are notes you should be taking either filling out in questions or on your graph itself. You want it to have an interpretation, right? Okay. We know what the slope represents. It represents speed or velocity. Now let's get into the general equation for wavelength, velocity. In our graph, we use period. And the reason why we use period is because period is in seconds. Seconds is easy to interpret. Hertz, not so easy. So our equation in our physics helper actually uses frequency. So because period is 1 over frequency, we can just substitute 1 over frequency into our original equation. And if I do a little manipulation, this is the equation you have in your physics helper. Wave speed equals wavelength, lambda, memorize it, times frequency. Frequency in hertz, memorize that too, Hz. This is the equation you've got in your physics helper. This is the other equation you have in your physics helper. Or maybe it's frequency equals 1 over period. Regardless, you only have 2 equations. All you need to know is how to use them. So, this is the conclusion for this post-lab assessment. What I want to talk about, though, is when we get into your worksheet, I'm going to give you some time to work on your worksheet today. You're going to have some standing waves. You're going to have some crests and troughs. You're going to need to draw these waves accurately. And you're going to have to interpret what is a period, what is a frequency, when they don't actually just tell you right off the bat.